Alright, before we start this set of problems, there's a few formulas you need to know. So write these down on an index card. The first one is the sum of interior angles of a polygon is 180 times n minus 2, 180 degrees times n minus 2. Each interior angle of a regular polygon is 180 degrees times n minus 2 divided by n. The sum of the exterior angles of a polygon is 360 degrees, and each exterior angle of a regular polygon is 360 degrees divided by n. And for all these problems, alright, it's where n equals the number of sides of the polygon. Okay? Now just a reminder, polygon is any closed figure like a triangle or a square or a rectangle or a pentagon. Okay, those are all polygons. So we're just going to count the number of sides for these formulas. N is the number of sides. And when it talks about a regular polygon, that's when all of the sides are the same length and all of the angles are the same measure on the inside. Okay? So there's a difference between a polygon and a regular polygon. Alright? So for example, a rectangle is a polygon, but a square is a regular polygon because all the sides are equal. Okay? So write this down and then let's start the problems. I'm going to keep this card nearby so when we solve these we'll see which formula to use. In which polygon does the sum of the measures of the interior angles equal the sum of the measures of the exterior angles? Well, the sum of the exterior angles is always 360 no matter what. So we want to know which one of these does the sum of the interior angles also equal 360. So the sum of the interior angles, so for interior, let's put sum of interior, the formula is 180 times n minus 2. Okay? And the sum of exterior, no matter what, it's always 360 degrees. So that's not even like a formula, that's just a fact. Okay? So we just start with the triangle. Alright, so for a triangle, we have 180 times 3 minus 2, because there are 3 sides. So that would be 180 times 1, so that's 180. Alright, so it's not the triangle. So then we look at a hexagon. That's a 6-sided shape, right? So 1, 2, 3, 4, 5, 6. And the sides don't have to be all the same length because it doesn't say a regular hexagon. So this is also a hexagon. Okay? The one that you're used to seeing is a regular hexagon. That's when all the sides are the same length. So for the hexagon, it's the same formula, 180 times, but this time there's 6 sides, minus 2. 180 times 4, that would be 720. So it's not a hexagon either. Alright, so let's also label these shapes. Triangle, hexagon. So now for an octagon, like a stop sign, okay, but again, all the sides don't have to be equal. 1, 2, 3, 4, 5, 6, 7, 8. So for an octagon, it's 180 times 8 minus 2. So that's 180 times 6, and that is 1080. And these are all degrees, by the way. So it's not the octagon either. So then we look at a quadrilateral. A quadrilateral is a 4-sided shape, like a square or a rectangle or a rhombus or a parallelogram. There's lots of them. Okay, any 4-sided shape. We have 180 times 4 minus 2, That's 180 times 2. That's 360 degrees. So that's our answer, quadrilateral, because the exterior angles are always 360 for all these shapes. But the only one that has also 360 for the interior, the sum of the interior angles, is quadrilateral. For which polygon does the sum of the measures of the interior angles equal the sum of the measures of the exterior angles? This is the same problem. Wow. And these are Regents problems, so you can see they like to give you this problem. So we're just going to put, but the choices are just out of order. You see that? They just gave us, and the choices are actually all the same. They're just in a different order. Triangle, hexagon. Oh, they gave us a pentagon instead of octagon. Quadrilateral and triangle. But let's go through the process. So first, its sum of exterior is always 360, and the sum of the interior is 180 times n minus 2. So for a hexagon, and we don't even have to draw the shape, that means 6 sides for a hexagon. So we have 180 times 6 minus 2, 180 times 4. That one was 720 degrees. Then we have pentagon, which has 5 sides. So 180 times 5 minus 2 is 180 times 3. Alright, and that is going to be, I don't know why I'm not remembering that, 540, that's what I thought. 540 degrees. Then we have quadrilateral, which is 4 sides. So 180 times 4 minus 2 is 180 times 2 is 360. So that's our answer because it matches the exterior angle, but we want to also just show the work for triangle, which is 3 sides. So 180 times 3 minus 2 is 180 times 1 is 180. And if you think about it, you already know the sum of the angles of a triangle, the sum of the interior angles of a triangle is 180, so the formula works. And for a square and a rectangle, it's 360. All right? So this formula works for any number of sided shape, which is a polygon. All right? Let's look at the next one. The sum of the interior angles of a polygon of n sides, okay, it's just our formula. Sum of the interior angles formula, 180 times n minus 2. It's this one. They just put the 180 last. That doesn't matter. The pentagon in the diagram below is formed by 5 rays. Okay, you can see the pentagon in here. By the way, those angles on the outside, those are the exterior angles. Okay, those are exterior angles. This one is an interior angle because it's on the inside of the pentagon. So what is the degree measure of angle X? This one out here. Well, we know that the sum of the exterior angles equals 360 degrees, no matter what it is. The only problem is that we don't know this exterior angle right here. Okay? So let's find that first. Let's call that Y. Now we know that this is a linear pair. So we know that Y plus 140 degrees equals 180 degrees. It's supplementary. These two add up to 180. So if we subtract 140, we get Y equals 40 degrees. So now we know that 40 plus x plus 68 plus 84 plus 60 has to equal 360. And then we just solve it like any equation. I'm going to add 40 to 68 to 84 to 60. So 252 plus x equals 360. Subtract 252. X equals 108 degrees. Okay? So that's choice 3. The number of degrees in the sum of the interior angles of a pentagon. A pentagon has 5 sides. And the formula for the sum is 180 times n minus 2. So 180 for the sum of the interior angles, it's 180 times n minus 2. So 180 times 5 minus 2, 180 times 3, 540 degrees. Okay? Let's put here sum of interior angles. I put INT for interior. What is the measure of an interior angle of a regular octagon? Look, each interior angle of a regular polygon, which an octagon is a polygon, we use the formula, we use the each interior angle formula, which is 180 times n minus 2 over n. So for an octagon, which has 8 sides, that means our n is 8. So we have 180 times 8 minus 2 over 8. That's 180 times 6 over 8. That's 1080 over 8. That's 135 degrees. Choice 4. So the measure of each interior angle of a regular octagon is 135 degrees. What is the measure of each interior angle of a regular hexagon? So this is the same type of a problem. Each interior angle is 180 times n minus 2 over n. But for a hexagon, there are 6 sides. So we have 180 times 6 minus 2 over 6 equals 180 times 4 over 6 equals 720 over 6. 120 degrees. Choice 2. We have a regular pentagon here. So that means that this side is equal to 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 this side. That's what the word regular means. And it also means that all of these angles are equal. That's what a regular polygon, that's what the word regular means. All of the angles are equal and all of the sides are equal. So what is the measure of angle AEB? AEB. Alright. This is actually a very tricky problem. Okay? Now, first let's find let's find the measure of each one of these interior angles of this pentagon. So the each interior angle formula is 180 times n minus 2 over n. Now for a pentagon, there are 5 sides. So we have 180 times 5 minus 2 over 5. 180 times 3 over 5. 540 over 5, which equals 108. Let's just double check that. 108. So that means that this angle is 108, this angle is 108, this angle is 108, this whole angle is 108, and this whole angle is 108. Now I'm going to take this triangle off of this pentagon and redraw it. A, E, B. And we know this side is equal to this side, and we know this is 108 degrees. Now we don't know those two small angles. We knew that the whole piece was 108, but we don't know what the two smaller pieces are. Okay? And they're not, we don't know anything about that. But if we look at this triangle, we can see that this is an isosceles triangle because 2 of the sides are congruent. So that means that these 2 angles, even though we don't know what they are, we know that they're the same. So let's call it x degrees and x degrees. And we know that all the angles of a triangle add up to 180. So we know that x plus 108 equals 180. So we know 2x plus 108 equals 180. Subtract 108. We know 2x equals 72. Divide by 2. We know that x equals 36 degrees. So that's the size of angle AEB. There it is. Okay? Tough problem because it takes a few concepts, right? And it puts it into one problem. That's the type of problem you can expect on the Regents because that's what they do. By the way, remember these are all Regents problems, every single one of these. Find in degrees the measures of both an interior angle and an exterior angle of a regular pentagon. Okay, so first of all, a pentagon has 5 sides. It wants to know the measure of each interior angle, which is this formula, and each exterior angle, which is this formula. So let's write that down. Each interior angle is 180 times n minus 2 over n. And each exterior angle is 360 divided by n. So for this first one, we have 180 times 5 minus 2 over 5. That's 180 times 3 over 5. That's 540 over 5. That's 108. Okay? And then for this one, it's just 360 divided by 5. And that is 72 degrees. Okay, so each exterior angle is 72 degrees and each interior angle is 108 degrees. And I just used the formulas. In which polygon does the sum of the measures of the interior angles equal the sum of the measures of the exterior angles? Yikes. We did this problem already. They asked it again. This time it's the same exact problem. Oh wait, that is a different sheet. I think we just finished then. 21, 22, 23, 24, 25, 26, 27, 28, and 29, yes. that is the end of this lesson.